All right, so the next thing we're going to look at is function composition. So we already talked about how we can take functions and kind of treat them as these separate parts that we can add and subtract and multiply and divide. And now we want to talk about what composition is. So the definition of composition, if you look it up, is the act of combining parts or elements to form a whole, or the resulting state or product. So when we talk about composing function or composition, think about what comes to mind when you think of that word, and you might think about a composition in terms of like a music composition, or if you're writing a paper, that would be you're composing or putting together, like an English paper. So you're taking, in the music example, you're taking notes and things like that, and you're putting it together to form a larger structure, a song or a melody. And for a paper, if you're composing something, you're writing words that are being combined into sentences that are being put into paragraphs and pages and so forth. So the same thing goes with functions. You can kind of take those functions and put them together piece by piece. It's kind of like Legos. So if I have, here's an example of a function, right? If I have, oftentimes we visualize functions as having an input and then having an output. So like think of this as like a function machine. And let's just say that this blue part right here, is a function. And let's say that this function simply, let's just say that it squares the number, right? So this function right here, if I plug in anything into this function, let's say I plug in 2, my rule here is to take whatever that is and square it, and then I can output something else. So out would come 4 here, right? Or if I plugged in like -5, then out would come 25. Now the way that I would write something like this would be, I would have to name that function. I could say this is, f of x equals, and the rule is to square it, so x squared. Let's say I have another function. Let's call it g of x. Let's say I have another function, and let's say that function just, let's say we take whatever input that we have, x, and we double it, and then let's say that we add 1 afterwards. So now I have another function, and let me just show you what I mean here. So I have one function that squares it, and let's put another function over here that's in green that is 2x plus 1. So it takes in the input, whatever number that is, it doubles it, and then I add 1 to it. So again, let me put another example here. So on the left, if I plug in 7, of course the output would then be 49. That would come out of that function. For this green function, or g of x, let's say I plugged in 7 as well. Well, if I plug in 7 here and I plug it into x and I double that, I'd get 14, and then adding 1, I would get 15. So I have two different functions that do two different operations, basically. Now, if I wanted to compose these functions, what I would do is do something like this. So let me get rid of these specific numbers. And let's say that I took this function right here and I connected it with this function right here. It would almost be like I'm taking this Lego piece and I'm going to plug it into this Lego piece so that this whole thing becomes one function. So what I mean by that is you can see my cursor here. If I plug something in right here, let's just say I use that same example of 7. Here's 7. If I take 7 and I drop it into this function and then I just let it go, then 7 would go into this function, and of course it would be squared, so that out comes 49. But then immediately after, the output 49 would now be dropped into the next function, and it would go through, its operations. So the output is 49, which now becomes the input of the next function. So 49 is then dropped into 2x plus 1. So then if I double that, that's going to be 98. And then if I add 1, I get 99. So this is an example of taking two functions, and now I'm putting them together. I'm composing them so that I'm sort of like connecting them up. So again, this visual, think about it. If I drop in some input, it runs through one function, and then immediately after, it runs through the next function right away, and then you get an answer. So if I were to drop in 7, and it runs through both functions this way, I get 99. Now, continuing off of this example, if we swapped the order of this, would it make a difference? Right? Like, what if I took the green, what if I took this function right here, and I took these Lego pieces, think back to when you were a kid and you started playing with Legos. Would this provide a different outcome? What if I just switch the order of them? So let me take this and make it smaller. Try that again. So I have that. And now I have this right here. So what if I switch the order, and again, let's use the same starting value just for example, right? So let's say I take in 7 and I drop it in. Would I get the same thing with this function composition? Well, let's take a look, right? So if I drop it in the green function first, I'd get 7. If I double that, I get 14, and then add 1, I would get 15. And now 15 is the output. Let's go ahead and drop that right into the next function, which is just to square that value. And 15 squared is 225. So you can see we do get different behaviors here, right? If I start with 7 in this order, I get 99. If I start with 7 in this order, I'd get 225. So these are different behaviors that I have. And this is, again, these are examples of what we call function composition. Now you'll notice that there's this notation right here. Let me just show you side by side what the notations would mean. So in this example, let's, the blue function here is we're calling f, or f of x. The green example is g of x. So since I'm using f of x, this order right here, the way that we would write this is I'm going ahead and I'm using f of x first. Whatever I get for f of x, whatever the output is, I'm immediately plugging that into g of x. So it would look like this. I would say this is g of f of x. That's what this example shows right here on the left. So again, whatever f of x is, right? I plug in some value there. And for this example, it was 7. I plugged in 7, I got 49. And then this blue part now becomes 49 right here. And now this is now the input of what I'm plugging into g. So I'm first applying f of x, and then whatever that output is, right here, then I'm plugging that directly into the next function. So I'm using I'm kind of wrapping these functions up like a present. And so you see there's a bunch of parentheses there. And you'll get used to the notation, and I'll keep saying that throughout these examples. But if I look at the other example, well, that's different. Now I'm starting with g of x here. So this example would say I'm starting with g of x. I'm going to go ahead and just apply that, okay? And and then afterwards, I'm going to apply f of x to that. So this would be an example of doing f of g of x, because I'm doing g of x, and then whatever I get for that, I'm plugging it right into f of x. And the first example is the other way around, where I have g of f of x. Whatever's in the innermost parentheses is basically what we're doing first here. So this notation you will get used to, but let's look at an example here, a couple examples. So example 3. Example 3 says we have f of x is 3x minus 4, and we have g of x, which is x squared minus 1. Again, we have two functions that are separate. And what we're trying to do here is take f of g of negative 3. Again, I'm going to write this in. How do you verbalize this this expression here? This is the way that you would say that is I'm taking f of g of negative 3. That's how I would say it out loud. And the first thing I want to do here is, you can certainly just do this algebraically, and once you get used to this, and at the end of the lesson, hopefully you gain confidence. But I want to show the visual example before I kind of just go through the problem. So let's think of it in terms of a function machine again. So what we're saying here, and let's say that the blue function is g of x. So that is x squared minus 1. And let's say that the green function is 3x minus 4. So this is what it would look like. This green part would be 3x minus 4. And so I have two functions, and I'm basically connecting them up, not in this way, but I'm doing g of x first. So I'm going to plug it in like this, right here. My original input, I actually have negative 3. Negative 3 is the value that I'm plugging in here. And so I'm going to drop negative 3 into this function composition. And all that means is I'm going to take negative 3, and I'm going to plug it into g of x. Well, if I go ahead and do that, I just do one step at a time, or one function at a time. If I take negative 3 and plug it into x squared minus 1, as a side problem here, that would be, negative 3 squared minus 1, and I can evaluate that to, that's going to be 8, right? So 9 minus 1 is 8. So the output of that is going to be 8. Well, now right away that 8 is being dropped into the next function, 3x minus 4. And now I'm going to go ahead and take 8 and plug it into the green function, or into f of x. So now I'm taking 3 times 8 minus 4. And I'm just evaluating that. Well, 3 times 8 is 24, and then minus 4 is 20. So at the very bottom here, I get 20. So the answer here, f of g of negative 3, that's a composition. And you basically do the inside first, right? So you're basically taking g of negative 3, plug in negative 3 into g, just like the warm-up. Think about the warm-up that we did, right? Right here, right? If you could do this, f of negative 6 and g of negative 4, and you followed through there of just, I'm just plugging in that input, plugging in that number into the function, and I get an output, well, then you should be able to connect that with doing that twice. So again, back down to here. I'm taking g of negative 3, and that alone is 8, but then I'm taking that 8 and plugging it into f here, and that gives me 20. So f of g of negative 3 is equal to 20 is my output. Okay, so let's look at the next one. The next one, I'm going to take this and I'm going to make this smaller. What is g of f of 5? Okay, well, if we didn't actually draw out, the visual here, we could simply just do the inside first. I could say, well, what is f of 5? What is f of 5? Well, I'm going to take 5 and I'm going to plug it into the function f. And so if I plug in 5 into f, that's going to be 3x minus 4. Let's do that right here. 3x minus 4. There's my f function. But I'm plugging in 5. So instead of x, I'm going to plug in a 5 here. So it's like this. So 3 times 5 minus 4, and that's equal to 15 minus 4, which is equal to 11. So this is equal to 11 right here. So f of 5 is equal to 11. But now, since there's a function composition here, I'm going to take what I got for that. F of 5 is 11, but now I'm going to plug that into g right here. So now I'm going to have g of 11, right? So let me write this a little bit different here. So like if my work was, if I was doing this separately and I said, what is f of 5? Well, then I get f of 5 is 11, right? So I could write this off to the side as, well, now since I figured out what f of 5 is, now my problem becomes g of, and I know what f of 5 is, that's 11, so now I have g of 11 because I just figured out that inside problem. So now I'm going to figure out what happens if I plug in 11 into the function g, and again I look to my function definition, and that's x squared minus 1. So that's going to be, what is 11 squared minus 1? And well, 11 squared is 121, minus 1 is 120. So g of f of 5 is 120. Now, if that's still a little bit strange, again, the visual to that looks like this. Make these a little bit bigger. Now we're going in the other order. So if I take f of x first, right, which is the blue function. Actually not. I'm taking f of x, which is the green function. My bad. Right, if I take the green function, and I use that first, the visual would be, I'm going to take 5, and I'm going to run it through these functions in this order. So I take 5, I plug it into 3x minus 4. I get 11. And then after 11 comes out, I'm going to plug it into the next function, which is x squared minus 1, and that's where I get the 120 there. Okay. I know I'm long-winded there, but I want to make sure you really see and can visualize that composition, because I think that visual helps. All right, and then, what happens if I do f of 2? I'll let you try these last two here. If you want to pause the video and try these problems here, this last one kind of being a challenge problem, but see if you can do it. All right, so what is f of 2? Well, that's no problem. I'm going to take, first of all, what is f of 2? F of 2, I'm going to go ahead and take 2 and plug it into f, which is 3x minus 4. So 3 times 2 minus 4 would be 6 minus 4, right? Which is 2. 6 minus 4 is 2. So this part right here, f of 2 is 2. Now if I take that and plug it into my function to the left, now I'm at, what is f of 2? Well, if I take 2 and plug it into the same function again, right? Well, of course that's going to give me 2 again, because that's not going to change. So my answer is going to be 2. In fact, you can see here that there's this relationship that if I plug in 2, I get 2. So you could maybe predict, what is f of 2, right? If I'm getting 2 every single time and I'm doing it 3 times, well then you could try this, but the answer is always going to be 2, right? Last example, g of f of 1, right? So in this problem, you have to just understanding the fact that it doesn't have to be 2 functions. You could do this 3 times or 4 times or an infinite number of times, so you can keep going through this process. Basically, you could have an infinite number of Lego pieces that you're just kind of smashing on top of each other. So, okay, if I have f of 1 right here, f of 1, well, if I plug in 1 into f, that's going to give me 3 times 1 minus 4. 3 minus 4 is negative 1. So this becomes a negative 1. So let me write this out again. So this would then be g of f of g of, and I did that first function, that's negative 1. So now I only have 3 more things to do. But now I'm going to do the next part right here, the innermost parentheses. So right here, what is g of negative 1? All right, I'm not going to write out all this work, but g of negative 1 right here. So if I plug in negative 1 into g, that'd be negative 1 squared, which is positive 1. Minus 1 is 0. So g of negative 1 is 0. So this becomes a 0. Okay, so now I'm going to keep writing this, and I'm going to say this is g of f of, and this middle part became a 0. All right, so next one up. So now I'm going to be looking at what is the innermost parentheses. What is f of 0? Well, going back to f, 3x minus 4, that'd be 3 times 0 minus 4. So that would be negative 4. Okay, so we're almost done then. So this is going to be g of, and now I know that this last one is going to be negative 4. And now I'm at my last function. What is g of negative 4? G, and that's negative 4 squared minus 1. So that would be 16 minus 1, which would be 15. So now this equals 15, and I'm done because there's no other function to plug into. I'm done with just this number here. So that's function compositions with numbers. And I hope that that gave you a good visual example of what this idea of composition means in math.